In today's discussion, we join Jasper and Lila, two enthusiastic students at a campus coffee shop, as they delve into the fascinating world of networking fundamentals. Hey Lila, I heard you were looking to understand networking fundamentals. Want to go through it together? Yes, please. I'm a bit lost on where to start. What exactly is networking and its fundamentals? All right, let's break it down. Networking is essentially the practice of connecting computers and other devices to share resources, exchange data, and communicate. The fundamentals of networking include understanding how these connections are made, how data is transmitted, and the protocols that govern these processes. Lila, got it. So why is networking so important? Jasper. Networking is crucial because it enables communication between devices and systems. It's the backbone of the internet, allowing us to access information, share files, and connect with people worldwide. Without networking, modern communication and data exchange would be impossible. That makes sense. What about the different types of networks? Jasper. There are several types, but the main ones are LAN, Local Area Network, covers a small geographic area, like a home, office, or campus. It's typically faster and more secure, ideal for connecting devices within a single location. WAN, Wide Area Network, spans large geographic areas like cities, countries, or even globally. The internet is the largest WAN, connecting millions of smaller networks. MAN, Metropolitan Area Network, covers a city or a large campus. It's larger than a LAN but smaller than a WAN, often used to connect multiple LANs within a metropolitan area. PAN, Personal Area Network, used for connecting personal devices like your phone, laptop, and smartwatch. Bluetooth and USB are common technologies used in PANs. Lila, I've heard of the OSI model. Can you explain that? Jasper. Sure. The OSI model, or Open Systems Interconnection Model, is a conceptual framework used to understand network interactions in 7 layers. Physical layer deals with the physical connection between devices, including cables, switches, and other hardware. It defines the electrical and physical specifications. Data link layer manages data transfer between 2 directly connected nodes. It includes error detection and correction and ensures reliable data transfer. Ethernet is a common protocol here. Network layer handles routing of data packets between devices. It determines the best path for data to travel. IP, Internet Protocol, is used at this layer. Transport layer ensures complete data transfer with error recovery and flow control. It includes protocols like TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. Session layer manages sessions or connections between applications, maintaining, establishing, and terminating connections. Presentation layer translates data between the application layer and the network, handling data encryption, compression, and translation. Application layer provides network services directly to user applications, like web browsers and email clients. HTTP, FTP, and SMTP are protocols at this layer. Lila, that's a lot of layers. How about the TCP/IP model? The TCP/IP model is simpler with 4 layers. Link layer combines OSI's physical and link layers. It handles hardware addressing and defines protocols for the physical transmission of data. Internet layer corresponds to OSI's network layer, responsible for logical addressing and routing. IP operates here. Transport layer, similar to OSI's transport layer, ensuring reliable data transfer between devices. It includes TCP and UDP. Application layer merges OSI's session, presentation, and application layers. It provides network services to applications such as HTTP for web browsing and SMTP for email. Lila, interesting. What are physical and logical topologies? Jasper, physical topologies refer to the actual layout of cables and devices in a network. Some common types are bus topology. All devices share a single communication line. It's simple and cheap but can be slow with many devices. Star topology. All devices are connected to a central hub or switch. It's reliable and easy to manage but requires more cable. Ring topology. Devices are connected in a circular fashion. Data travels in one direction, reducing collisions, but if one device fails, the whole network can be affected. Mesh topology. Every device connects to every other device. It's robust and reliable, but expensive due to the number of connections needed. Logical topologies, on the other hand, describe how data flows within the network, regardless of its physical design. Let's dive deeper into logical topologies. Bus, logical topology. All nodes receive the data simultaneously. but only the intended recipient accepts and processes the data. This topology is straightforward, but can lead to collisions if multiple devices send data simultaneously. Star logical topology. Data sent from one device is relayed by the central hub to all other devices on the network. However, only the intended device processes the data. This is efficient and reduces the risk of collisions. Ring logical topology. Data travels in a circular fashion from one device to the next until it reaches its destination. Each device has exactly two neighbors for communication. This reduces the chances of packet collisions, but a break in the ring can disrupt the entire network. Mesh logical topology. Every device has a dedicated point-to-point connection to every other device. Data can travel from any device to any other device without needing to pass through intermediate devices. This is highly reliable and fault-tolerant, but it's complex and expensive to maintain. Hybrid logical topology combines elements of two or more different logical topologies. For example, a network might use a star topology within individual departments, but connect those departments using a bus or ring topology. Lila, I see. So logical topologies are more about how the data travels rather than how the cables are laid out. Exactly. Physical topologies are concerned with the actual setup and connections, while logical topologies focus on the path data takes and how network resources are managed and utilized. And what about networking devices? Networking devices are hardware used to connect and manage network segments. The main ones include routers, direct data packets between networks, determining the best path for data to travel across interconnected networks. They operate at the network layer of the OSI model. Switches connect devices within a single network, forwarding data to specific devices rather than broadcasting to all. They operate at the data link layer. Hubs, basic devices that connect multiple Ethernet devices, making them act as a single network segment. They broadcast data to all connected devices and operate at the physical layer. Bridges connect and filter traffic between two or more network segments, reducing collisions and improving performance. They work at the data link layer. Gateways act as a gate between two different networks, often translating data between different protocols. They can operate at various layers, depending on their function. Modems convert digital data to analog signals and vice versa, enabling internet access over telephone lines. They operate at the physical layer. Firewalls monitor and control incoming and outgoing network traffic based on security rules. They protect networks from unauthorized access and can operate at various layers. Thanks, Jasper. This is starting to make a lot more sense. Anytime, Lila. Networking is a fascinating subject once you get the hang of the basics. Just keep exploring and don't hesitate to ask questions. And remember, practice is key. Try setting up your own small network at home to get a hands-on understanding. I will, thanks. I'm excited to dive deeper into this. Before we wrap up, let's quickly compare the OSI model and the TCP/IP model, since they often come up together. The OSI model is more theoretical and is used as a guideline to understand and implement network protocols. It's comprehensive with its 7 layers, which helps in pinpointing where a problem might occur in the network. On the other hand, the TCP/IP model is more practical and widely used in real-world networking. It combines certain layers for simplicity and focuses more on the protocols used in the internet and similar networks. That's good to know. So, while the OSI model is a more detailed guide, the TCP/IP model is what's actually implemented most of the time? Jasper, exactly. Think of the OSI model as a map and the TCP/IP model as the route you take. Both are essential for understanding how networks operate and for troubleshooting. As Jasper and Lila continue their exploration of networking fundamentals, their enthusiasm and curiosity pave the way for a deeper understanding of this essential field. Whether you're new to networking or looking to expand your knowledge, understanding these fundamentals is key to navigating the complexities of modern technology. Thank you for joining us today. We hope you found this discussion informative and engaging. Stay tuned for more insightful conversations and tutorials on our channel. Don't forget to like, subscribe, and hit the bell icon for notifications. Until next time, happy networking.